This is the 7.1 to 7.2 area volume review worksheet. So through these problems, we're going to see a series of area problem, disk method involving volume, and washer method involving volume. So number one, we start off with finding area. We have a graph, a curve, x squared minus 2x. We have the line y equals 8. Calculate the intersections. So the way we calculate intersections is we set the curve equal to the line. We set the two equations equal to each other. Once we set them equal to each other, make sure we bring everything over to one side, get the 0 to show up so that we can factor. And when we factor, we can solve. We get x equals -2 and x equals 4. In our area formula, we can now evaluate using top graph minus bottom graph. So we draw a representative rectangle that connects from one graph to the other. And we see the top of my rectangle is on the 8, the bottom is on the x squared minus 2x, so we do top minus bottom. And we want to make sure that we protect the bottom function with a set of parentheses so we don't forget to distribute. From there, we can either use our calculator or we can work this out by hand, use power rule, evaluate upper and lower bounds, and we get a calculation of 36 square units for that area. All right, for number two, same shaded region, but now we're rotating about a line y equals 8. So I'm going to highlight that axis of revolution with the red line. So notice that this axis of revolution is up against the flat surface of the shaded region. Notice that there's no gap at all. So because of that, we know that we only need to rely on one radius, and that radius, that means we only need to do this method. Okay, so radius is extends from the axis to the further boundary, and we do top minus bottom. The top is sitting on the 8. The bottom of the radius is sitting on the curve, so 8 minus parentheses x squared minus 2x. Now this represents the radius of our infinitely thin circular disks. So then we enter all that in our calculator. Our bound is still the same from -2 to 4, left and right bound, -2 to 4. Enter in our calculator, leave the pi out of your calculator, and you'll get a decimal value which you can convert to a fractional value, 1296 over 5, and attach pi to that answer. All right, number three, we're looking at volume again, but now we are rotating about a different line. Same shaded region, but rotating about a different line. And here now notice that our axis of revolution is no longer up against the flat surface. It's touching, but there's an obvious gap, right? So because of that gap, there's going to be a hole that's going to be created out of this object after it gets rotated. And so we have to make sure we subtract that out. We have to draw two radius, one radius that extends from the axis to the furthest boundary, and then another axis that extends from the axis to the closer boundary. Okay, we do top minus bottom. The top is sitting at the 8. The bottom is sitting at the -1. So 8 minus -1, that's 9. Little radius, top minus bottom. Top is sitting on the curve, the x squared minus 2x. Minus, okay, the bottom is sitting at the -1, so the two negatives become positive. We know this is going to be washer method, so we do big radius squared minus little radius quantity squared. Enter all this in our calculator. Still the same shader region from -2 to 4. Leave pi out of your calculator. Get it all the way down to 1944 over 5, and then just insert that pi to our answer. Okay, number four, calculate the area of the shaded region. So first up, we want to set the two equations equal to each other so we can find the two intersections. So we have x cubed plus x squared equal to 2x squared plus 2x. Set them equal to each other. Bring everything over to one side. Get that 0 to show up on the other side. Factor an x out. Continue factoring. We get x minus 2, and x plus 1. So we have two three intersections here. We have 0, 2, and negative 1, but we're only calculating that region between 0 and 2. And 2. All right. So then we do top minus bottom. The top is going to be that 2x squared plus 2x. The bottom is going to be the x cubed plus x squared. So we do top function minus bottom function. Again, make sure you separate that bottom function out with a set of parentheses. Distribute this through. Our bounds are from 0 to 2. Enter in our calculator or work this out by hand using power rule. Plug in upper bound minus lower bound. We get 8/3. No pi here because we're not rotating around anything. There's no circles involved. So just 8/3. Right, number 5, same shaded region as number 4. So our bounds can carry over. But now we're rotating this shaded region in a circular way around this dotted line, y equals -3. And now notice that there's a complete gap there. It's not up against a flat surface, so we know that we have to involve two different radius. One radius that will extend from the axis to the furthest boundary, and then the other going to be from axis to that this closer boundary. So the result of this is going to be kind of a ring-shaped, or more like a lampshade kind of a shape here. So after it gets rotated, it's going to kind of it's going to be this hollow portion that we have to make sure we account for. So we do top minus bottom. The top is sitting at the 2x squared plus 2x. The bottom is sitting at the -3. So we say 2x squared plus 2x minus -3. That's big radius. Little radius is going to be from the x cubed plus x squared minus the -3. Okay. Our bounds we can carry over from number 4, from 0 to 2. Big radius, quantity squared, minus little radius, quantity squared. Enter all this in our calculator. We get 4016 over 105, and then include that pi on our own cubic units.